Hello everybody, and welcome to today's webinar, What's New in Tigera Calico, an update on new features and product enhancements. Today, our speaker is Eddie Esquivel, but before we get to Eddie, I'd like to go over a few housekeeping items and get everybody familiar with the BrightTalk webinar interface. First off, today's webinar will be available on demand after this live session and will be accessible through the same link that you are using now. It should take about 15 to 20 minutes for this webinar to be live. Copies of today's slides can be made available. All you have to do is email contact@tigera.io to request your copy of the slides. And most importantly, we would love to hear from you today. So if you have questions for our speaker, please feel free to ask them at any time using the Ask a Question tab in your BrightTalk interface. If Eddie feels like he's able to, he will get to those questions as he goes. If not, we will have a robust Q&A session at the end. We will try to take on and answer any and all questions. So, with that, I am pleased to introduce today's speaker, who is Eddie Esquivel. Eddie is a senior solutions engineer at Tigera. He's worked in technology for the last 20 years, first as a developer, I believe with a large Fortune 100 financial institution, and then more recently as a solutions engineer. So he's gone from development over to the solutions engineer side. And over the last few years, he's been really focused on the Kubernetes space with experience at CoreOS and now at Tigera, of course. In his spare time, he lives in New York City and enjoys exploring it with his wife. So, without further ado, I will hand it over to Eddie, and we are in his good hands for this hour. Eddie?
Hey, thanks, Michael, and welcome all to the webinar. Looking forward to walking through the material with everyone. Today, we're going to go ahead and just do a brief overview of what Calico is, how it works. I think it should be interesting to folks on the phone, and then we'll dive right into some of the new features. Without much further ado, let's jump into it. So, Calico. For those that are familiar with Calico, know that it's basically become the de facto standard for networking in Kubernetes. Think of it as networking for containers. It's an open source project, commercially backed by Tigera. And that we know of, it powers about 100,000 Kubernetes clusters, a little over it at this point. So definitely happy and proud of the work that we've done with that open source project. So you might ask, okay, Tigera, Calico, great, what's the difference? So first and foremost, Tigera Calico is open source. It's obviously scalable, at the biggest scales, we've seen it over 5,000 nodes. But where does Tigera Secure really fit into it? Well, Tigera basically productizes the Calico open source project, right? So anything that you would think that you would need in order to roll into production with Calico, that's essentially what we go ahead and accomplish with Tigera Secure. So in terms of visibility, right, it's great that I have policies, it's great that I have YAML. Let me go ahead and actually view these in the GUI. Why don't I go ahead and also leverage tiering in order to have some sane constructs around managing all these policies. Let's go ahead and grab those flow logs and dump them into whether it's Splunk or Elasticsearch and actually do some machine learning on it. So various different aspects that we go ahead and attempt to productize in that open source project. And we're trusted by a myriad of companies out there, right? For a company that's only 3.5 years old, truly an enviable customer list here of folks that trust our tech and then, appreciate what we're doing in terms of productizing open source Calico. We do have definitely some strategic partnerships, in terms of all the cloud providers, Azure, AWS, Google, IBM. They all essentially allow for Calico to be deployed. Google actually takes it a step further and not only leverages us for the authorization, but also for the CNI, which is really cool. Also happy to be working with a lot of the on-prem customers or on-prem companies, Red Hat, Docker, which essentially also allow for our software to be deployed and fully supported, integrate with those Kubernetes stacks. So what can Calico do for me? At a basic level, it basically hands out IPs to your pods, right? So you have a distributed system, you have distributed applications running on these different hosts. How do I get an IP to a pod, and how do I route between pods? That's essentially what Calico does. But we also go ahead and, because we're doing the routing for you, we also go ahead and allow policies to be deployed that basically dictate, which pods can talk to which pods. We take it up into the stack, into layer 7, leveraging Istio as well, in terms of, actually being able to secure HTTP endpoints. So just a visual representation of what that is. We'll have the, I guess the text didn't come across, but essentially the first 2 rows are common across Calico and Tigera Secure, and then the latter rows, the management UI, the continuous compliance, and so forth, are all Tigera Secure specific. So let's go ahead and just do a brief overview in terms of how Calico works. And this is, it's nice to talk about new features, but it's also nice to lay some groundwork in terms of how Calico actually works. And we'll spend the next 10 minutes walking through some of this basic functionality. So let's go ahead and start with the host. Right, at its basic level, we have a host, and we have a pod on said host. Right, so we're going to go ahead and give that pod an IP 1.2.3.4. So if we're on the host and we want to route to that pod, how do we do it? Well, the first thing that needs to get set up is what we could call a V pair, right, where the pod itself is going to have an ETH0 interface. So we're going to go ahead and have this paired up with a Kali interface on the actual host. So once that basic plumbing is set up, we can create a route on that host. So basically any traffic that needs to go to 1.2.3.4 is going to go ahead and get pushed through the Kali interface and into the pod. Right, so this is basic routing to the pod from the host. We're obviously working in a distributed environment, right? So we're probably going to have multiple hosts. So we have host 1 as 172.0.0.1. We're going to have host 2 as 172.0.0.2. We're going to have a network. We're not going to be particularly specific about the type of network, whether it's layer 2, layer 3, adjacency, basically a network that allows us to route from one host to the other. And if we take a look at a route table on that other host, we're going to see a 1.2.3.4 entry. And if we want to get to that IP, we're going to have to go ahead and route over to 172.0.0.1, basically host 1. Right? So we now have a way to route both locally and from other hosts to that host 1, and specifically to that pod. Right? So this is what a distributed route table would look. And obviously, if we have multiple pods, we would have similar setup for the other pods, right? So we have a second pod on that second host, 5.6.7.8. You're similarly going to see a route to the Kali interface on that host 2. And then from every other host, we're going to have to route to host 2 for that pod IP, and then on to the Kali interface, right? So this is what, just a microcosm, if you will, of what your route tables look across your Kubernetes cluster. So how do we go ahead and, let's go ahead and talk about how we actually make these routes happen. We're going to start with how the local routes are set up, and that's where the CNI comes into the picture. The CNI is going to go ahead and set up that V pair and create that initial route, right? So the pod's going to get scheduled onto the host. It's going to go ahead and call the CNI. The CNI is going to go ahead and create that V pair and that route. And that's great. That's how we would route from the host to the pod. But again, how do we go ahead and distribute these routes across other hosts? Well, that's where our friend Bird comes into the picture. And Bird is an open source project that does a lot of things, but we specifically use it for BGP. In terms of routing BGP, leveraging BGP to go ahead and distribute the routes across multiple hosts. So what that means is, once that route goes ahead and gets created on the host, Bird is going to go ahead and watch for that. Going to understand that there's a new route that it needs to go ahead and propagate throughout the network. It's going to go ahead and communicate with other birds in the cluster, and those birds are then going to go ahead and create that route on locally on the box, right? So once we get to this picture, we basically see basic routing and some basic functionality in terms of on-host routing or creation of routes, and also across multiple hosts, the distribution of these routes via bird. Okay, some more questions that we have to ask though. Okay, where do these routes get stored? Where does policy come into the picture? How do IPs get handed out? How does bird know what nodes to distribute? And that's really where the scratch pad comes in. It's etcd in Kubernetes case, though we're not too hung up on what the data store is. We just need a key value pair. But etcd is a great fit and typically what is being used in Kubernetes clusters nowadays. So etcd is going to actually configure, we're going to go ahead and configure etcd via Calico Cuddle or Calico CTL. That's how we're going to go ahead and create the IP pools. We're going to go ahead and push policies into Calico. There's some overlap between what we can do between Calico CTL and kubectl. For example, all the policies can be applied via kubectl. So a lot of the, in-depth, the peering, the IP pools, the node pools, all of those sorts of things would be managed via Calico CTL. So the first thing that we really pull out of etcd or out of the key store via confd is all the nodes and all the BGP configuration. So bird is going to learn about every other node in the cluster from etcd. Confd is a small open source project that basically watches etcd and can dynamically update the configuration in bird, right? So if the cluster is growing or reducing in size, scaling up or scaling down, etcd is going to go ahead and reflect those changes. Confd is going to watch that and push the changes into bird. So if bird needs to go ahead and propagate routes to new hosts, they can go ahead and do that. So the other component that's key here is in terms of the policy enforcement, right? So you're going to create policies that are going to say, based on labels, this pod can or cannot talk to this other pod. That's going to be stored in the key value store, etcd typically, and we'll go ahead and push that policy into the local Felix. And Felix is going to go ahead and leverage, whether it's IP tables or eBPF in the latest version of Calico, it's going to go ahead and leverage these two mechanisms in order to go ahead and enforce these policies. Okay. So one of the other things that CNI does for us is go ahead and push metadata into etcd. So for example, once the pod gets scheduled, there's going to be some very important metadata that we need to push back into etcd. So for example, maybe the name of the pod, any associated labels, the IP, all the information goes into etcd and is then leveraged by Felix in order to go ahead and do the policy enforcement, right? And that's really where the mapping of labels and IPs comes to bear, right? Because again, you don't want to create policies that deal with static IPs. You want to deal with policies or manage policies that deal with labels. A much cleaner construct for handling policies within a Kubernetes cluster. So there's another aspect here that we hadn't mentioned yet, and it's how do we actually assign IPs? So there's another component called the IPAM, IP address management, which is basically going to go ahead and understand what IPs are available and assign them to the pods. So the way Calico works is, we wouldn't want to go ahead and just grab IPs 1/32 at a time, right? Because that basically, you can think about what that would do to our route table. The way Calico works is, by default, we're going to grab /26 pod siders, assign that to a host, and IPAM is going to go ahead and grab from that pool of IPs an IP and assign it to the pod. And the Calico IPAM is actually pretty intelligent in that if we were to, for some reason, exhaust all the IPs in the /26, the IPAM can either go ahead and grab another block But if for some reason there was no more blocks to be handed out, no more /26 blocks to be handed out, it can actually grab an IP from other instances and assign it to any pods locally. And one of the key features that we'll go ahead and describe in a little bit is being able to manage the default size of these pod siders, right? Default is /26. There's some pros and cons or trade-offs, better said, from going smaller or bigger, and we'll discuss that in a little bit. But here, folks, is a basic picture of how Calico works. You're going to notice there's a few different components here, Felix, Bird, CNI conf. If you're running Calico in your cluster and you do a kubectl get pod -namespace kube system, you're going to see Calico node running in there. And if you were to exec into Calico node, you go ahead and see these different processes running inside there. If you did a PS, for example, within the Calico node pod. So at a high level, this is basic functionality of Calico. There's some caveats, as you can imagine. For example, the VXLAN functionality is actually driven by Felix. But by and large, this is basically how Calico works at maybe a 100-foot level. So let's go ahead and move forward now, and let's go ahead and discuss some of these new features from the last year, really. So we've had a flurry of releases here over the last year, starting with 3.3 back in November of 2018, which seems like an eternity at this point. But you know, from 3.3, 3.5, 3.7, 3.8, just a myriad of releases with a lot of key features, and we're going to go ahead and describe some of these key features now. So the first one we want to go ahead and talk about is in-cluster route reflector support. And this is really a scaling concept, right? So if you were to just deploy Calico on your cluster, and you would have what we would call a full BGP mesh, you would basically have every host have a TCP connection to every other host. Remember, Bird is actually having to propagate the routes to every other host. So if you have a 100-node cluster, on any given host, you're going to have 99 TCP connections reaching out to every other host, right? So at 100 hosts, that may not be an issue, but if we get up into, you know, the massive scale, web scale, 1,000 nodes plus, that amount of, you know, TCP connections becomes untenable. So one of the key features is being able to leverage reflectors to just have a couple of TCP connections to these reflectors, and then rely on the reflectors to go ahead and distribute the routes to all the nodes in the cluster, right? So really anything maybe above a couple hundred nodes, we would fully invite our customers to go ahead and start thinking about ways to scale the cluster, typically done via a route reflector. Another feature which we alluded to earlier is configuring the block sizes, right? So again, the default is a /26. That gets you X number of IPs to be able to assign to pods on a host. But you can actually increase or decrease that, right? If you increase that block size, it means there's going to be fewer blocks available per host and potentially fewer routes. But you would want to make sure that you have at least as many blocks as there are hosts, right? You would want to avoid the situation where you've exhausted blocks and Calico now has to borrow single IPs from other hosts in order to fulfill the pod allocations, right? Again, we need to think about this in terms of scaling. You can also reduce the block size. You know, potentially you would have more routes, but there's a nice trade-off that you would have these blocks fairly distributed amongst the hosts, right? For whatever reason, you may have some, you know, maybe pinning more workloads to a specific node, and you would be able to distribute these blocks more evenly across your hosts. Another interesting feature that we've rolled out in 3.4 is advertising service cluster IPs to your network gear. So for example, you know, Bird is obviously going to be, you know, distributing the pod IPs, but what we've actually done in this version, 3.4, is allow you to go ahead and start advertising service IPs. So typically, if you want to route to a service, you would need a node port and ingress to go ahead and route to these services. This allows for native layer 2 routing and load balancing across services. Obviously trade-offs in that you wouldn't get some of the features of ingress. You wouldn't be managing HTTP requests, for example. But I think this is a great feature if you really think about, if you're trying to think about just basic layer 2 connectivity, this is a great feature. So another feature here, go ahead and click forward, is host endpoint protection. So host endpoint protection is something that we've had with Calico for a while now. But what we did in 3.4 is basically allow you to go ahead and actually secure node ports from pods within a cluster. So what this means is host endpoints is a pre-DNet policy, right? So if you're in a pod and you're trying to access a node port, you could potentially lose sight of what the source and destination address is. But by making this a pre-DNet policy, you can actually secure traffic as they're coming from pods within a cluster, right? So additional security there. And I see a question here in terms of, from a couple of slides back, how many route reflectors are recommended in, let's say, a 100-node cluster. So typically you would have 3 route reflectors, and you would peer every node to 2 of those route reflectors. And it's just for high availability and just HA really from a route reflector point of view. So how are route reflectors get deployed? Daemon on selected host. So route reflectors typically could be network gear, much like you have a top-of-rack switch. You could have a network gear that would act as a route reflector, and actually you could leverage it as that. There's also the possibility of having a software-based route reflector. You would potentially put that on 1 node per rack. The caveat being that you now have a node dedicated to a route reflector, right? So additional hardware there that you would have to work with. But either or are valid options. Okay, so keep the questions coming. We'll answer them as they come up. Okay. So moving right on, version 3.5 feature is IP address allocation based on topology. So for example, if you have multiple racks, or if you're an AWS or a cloud provider and you have this notion of an availability zone, it may be useful to go ahead and assign IP addresses based on the topology, right? And this may be useful in cases where you have a firewall. Not that we would advocate a firewall, but if you wanted to use a firewall, you could go ahead and stick a firewall between a couple of racks, and you could create firewall rules that would rely on the fact that a certain set of IPs is in one rack and another set of IPs is on the other rack, right? So this is one potential use case for actually leveraging network topology for the assignment of IPs. Another interesting feature in 3.6 is selectors with substring match. So when we do policy evaluation, you're going to get the basics, equals, not equals, inset, not inset. But we extended the selector matching with a few different features here in terms of, contains string S, starts with string S, ends with string S. And this can be useful, for example, we have lots of customers with multiple deployment environments, say a development cluster, a staging cluster, and a production cluster. And they want to create a label taxonomy that indicates by the label what environment it's being deployed in. So for example, they may have a front-end application with a label that says front-end dash dev, or front-end dash staging, or front-end dash production. If you didn't want to have to change the policies across these clusters, you could go ahead and create policies that leverage the fact that it starts with front-end, this label does, and go ahead and leverage that starts with mnemonic in order to go ahead and reference those labels, right? So it just makes it easier to go ahead and propagate policies through environments if you did want to have environment-specific labels. Support for IPAM with KDD, typically, again, we're running in Kubernetes clusters and we want to leverage the API server in order to go ahead and, push and pull policies into and out of etcd. Well, instead of you having to either leverage your own and manage your own etcd cluster or have to plug directly into the etcd cluster, this allows for just much cleaner installation, frankly speaking, where you can just leverage that Kube API. And one of the nice things about leveraging Kubernetes in order to talk to etcd is that you get secure communications out of the box, as well as RBAC, right? So just a much cleaner, simpler way, and really the way most folks are installing Calico in production nowadays. So in 3.7, we also rolled out native VXLAN encapsulation. So we had IP and IP encapsulation, but there's some networks that don't allow for IP and IP traffic, and I'm looking at you, Azure and DigitalOcean. So for these cloud providers, we basically created VXLAN, and you can happily run that overlay on either of those cloud providers. So if you have an AKS cluster and you're leveraging Calico, chances are you've already figured this out and are running in VXLAN mode on those cloud providers. In 3.8, we have an IPAM utilization report. View the IP address available essentially via Calico Cuddle. So for example, before this feature was there, if you had one IP available or a million IPs available, you had no real easy way of being able to discern that. But with this new feature, it makes it super easy to just go ahead and get a quick report and understand how many IPs you have free in an IP pool. So those were some of the key features we wanted to highlight over the last year. Again, you think of Calico as the open source project, and we thank you for using Calico. But if you really wanted to go ahead and productize or productionalize, if you will, Calico, fully encourage you all to go ahead and sign up for a demo on the website. We're trying to attack the few different pillars here that most folks would need to attack. For example, zero trust network security, visibility and threat detection, and continuous compliance. So we'll pause here for questions. Otherwise, I'll hand back to Michael.
Yeah, thank you, Eddie. So if you guys have any more questions, please feel free to go ahead and type them in. I know there's a little bit of a delay on the questions actually arriving to us, so we're going to go ahead and hold here for a couple. But while we're waiting, I'd like you guys all to know about our next webinar coming up, which is all about Kubernetes and Helm and network security. So this one will be a great webinar. It is being put on by Brandon Joza, a solutions architect at Tigera, who actually wrote a version of Helm that is in Red Hat, co-authored. So he's very knowledgeable on Helm, and it'll be a great webinar. So please do attend. Okay, so we had a question here. Eddie, let me see here.
Yeah, I'll go ahead and take that. Yeah, so the question is related to network policies. Can I confirm if we use the Kubernetes API service data store, Calico CTO is not required to manage network policies? And yes, that is 100% correct. You could do a kubectl apply-f with your policies, and away you go. Feel free to use kubectl for the application of policies. Calico CTL, you can go ahead and head over to our documentation on docs.tigera.io or docs.projectcalico.io, and you'll be able to see the reference information in terms of the different things that you can do with Calico Cuddle, and it's really based on managing some of the BGP peering, so like call it the nitty-gritty of the networking, would still be managed by Calico Cuddle. Okay, so great question.
Yep. Yeah, and just one thing, Eddie, the actual address for its project is at docs.projectcalico.org.
Oh, wonderful. .org versus .org.
Yep.
Great, thanks.
Yep.
For catching
Yep.
up.
Yeah, and I would say about Calico, there is 4 years of sweat equity in this product. So, yes, you can do it yourself, but I think I would give Calico a try because they've already worked through a lot of the issues that you may run into. That would be mine.
Yeah, great. And then, I guess there was a second part of that question in terms of kubectl resources.crd instead to manage network policy. We would recommend you work through the YAML, the network policy. That's a much easier way to go ahead and manage. So think about YAML. At a minimum, you can put YAML in GitHub or something and start actually managing your policies through this notion of GitOps. Okay. So how can I use Calico to monitor traffic? So Calico obviously does the routing, obviously does the policy enforcement. If you really wanted to monitor the traffic, that's where Tigera Secure would come into the picture. We have a nice GUI that helps you visualize the traffic. Also, we have all the flow logs, all that plumbing set up, so we can actually grab all this network traffic, throw it into an Stack, throw it into Splunk, and actually do some visualization on top of that.
So I don't care about it.
All right.
Okay. Well, if there are no further questions, the other webinar that I would recommend you guys all seeing is an on-demand webinar that we have on our website that we did with AWS and Atlassian, where it's a case study where essentially Atlassian spends most of the time presenting how they approached network security and their move to the cloud and to Kubernetes. It's a really great informational webinar. If you haven't watched it, please do go give it a watch. It's a good one. Okay. Well, I don't see any further questions coming in. So I guess with that, I would like to so Eddie, thank you so much for joining us and presenting. It was a great technical webinar, and I think there's a lot of good information in that. So thank you. And so thank you all for attending. Once again, if you would like a copy of today's presentations, please email contact@tigera.io. And this webinar will be available for viewing on Bright Talk and also on our website very shortly. So once again, thank you all for attending, and Eddie, thank you so much.